What is ionic bonding in ceramics? Explained simply. Have you ever wondered how ceramics are made so strong yet so brittle? The answer lies in something called ionic bonding. Let's break it down in a simple way. Ionic bonding happens when a metal atom gives away electrons to a nonmetal atom. This process creates positively charged metal ions, known as cations, and negatively charged nonmetal ions, called anions. These oppositely charged ions are like magnets. They attract each other strongly due to electrostatic forces. This attraction forms a stable bond, which is essential for the structure of ceramics. Ceramics usually consist of metal and nonmetal elements that have very different abilities to attract electrons. This difference is known as electronegativity. When the metal atom loses electrons, it becomes a cation. Meanwhile, the nonmetal gains those electrons and turns into an anion. The arrangement of these ions is crucial. They line up in a way that maximizes the number of opposite charges next to each other. This setup helps maintain electrical neutrality and forms a tightly packed crystal structure. The strength of ionic bonds is one reason why ceramics have high melting points, stiffness, and hardness. They are also resistant to corrosion. However, there is a downside. Because the ionic bonds are strong and non-directional, the ions cannot slide past each other easily when stress is applied. This leads to brittleness. When a crack starts, it can quickly grow and cause the material to fail suddenly. Ceramics often contain both ionic and covalent bonds, but the ionic character is usually more dominant, especially in materials like aluminum oxide. The balance between these types of bonds affects properties such as thermal expansion and mechanical strength. Understanding ionic bonding is key to grasping why ceramics are tough yet can break unexpectedly. The inability of ions to move under stress means that once a crack starts, it can lead to failure without warning. This behavior is important to consider in engineering applications where ceramics are used. In summary, ionic bonding in ceramics involves the attraction between metal cations and nonmetal anions formed by electron transfer. This bonding results in materials that are strong and stiff but also brittle, directly influencing their mechanical behavior.